The night sky appears to us as a vast, glittering canvas, alive with the light of a trillion distant suns. When we look up, we feel a sense of connection to something immense, a feeling that we are part of a grand cosmic drama. Yet for all its visual splendor, the universe is eerily quiet. For decades, we have aimed our most sensitive instruments at the heavens, listening for a single, intelligent whisper from the void. And we have heard nothing. This profound and unsettling observation lies at the heart of one of astronomy's most compelling puzzles, the Fermi Paradox. The paradox poses a simple, yet deeply challenging question. Why is space so quiet? The logic behind the paradox is straightforward and difficult to refute. Our galaxy, the Milky Way, contains hundreds of billions of stars. We now know that planets are not a rarity. They are the common companions of these stars. A significant fraction of these worlds likely reside within what astronomers call the habitable zone, a region where conditions might allow for liquid water to exist on the surface. Given the sheer number of potential cradles for life, it seems statistically inevitable that life would have arisen elsewhere. And if it has, some of it would have had billions of years to evolve, develop intelligence, and build a technological civilization. This leads to the central conundrum. To truly grasp the weight of the Fermi paradox, we must first contend with the staggering scale of the cosmos. Our minds are not built to intuitively understand the numbers involved, but we can try. Let's begin with our own galaxy, the Milky Way. Current estimates suggest it contains somewhere between 100 billion and 400 billion stars. For every single person who has ever lived on Earth, there are dozens of stars in our galaxy alone. It is a city of suns so vast that light itself takes 100,000 years to travel from one end to the other. The universe is huge. Now, let's zoom out. Through our most powerful telescopes, Hubble and the James Webb Space Telescope, we peered into a tiny, seemingly empty patch of sky and found a cosmic metropolis teeming with galaxies. Astronomers now estimate there are perhaps 2 trillion galaxies in the observable universe. Multiply galaxies by stars per galaxy, and you arrive at a figure beyond comprehension, likely more stars than grains of sand on all Earth's beaches. It is not a question of a few lottery tickets. It is a question of trillions upon trillions of chances. Each star, a potential system. Each system, planets, and with the right conditions, a potential for life. The universe is not a small, empty room. It is an endless ocean of possibilities. For much of human history, the existence of other planets was speculation. That changed in the last 3 decades. Thanks to Kepler and TESS, we have entered a golden age of planet hunting. Planets are not the exception. They are the rule. Nearly every star in the night sky has at least one planet. The galaxy is not just full of suns, it is full of worlds. Many look like Earth. Astronomers target rocky planets in the Goldilocks zone, not too hot, not too cold, allowing liquid water on the surface. Since life as we know it depends on water, this is a critical prerequisite for habitability. We've confirmed thousands of exoplanets, with dozens rocky and inhabitable zones. Extrapolations suggest tens of billions of Earth-sized worlds in the Milky Way alone. Around sun-like stars and red dwarfs, promising real estate abounds. Not thousands, not millions, but potentially billions of promising worlds. Many orbit stars much older than our Sun, giving life a possible head start of billions of years. The raw materials for life are widespread. Water helps life start. The silence we hear isn't from a planetless galaxy. It's from a galaxy teeming with worlds, many with life's ingredients. Astronomers find many Earth-like planets. The paradox sharpens. So why amid such abundance is the cosmos so quiet? Our perspective is bound to human lifespans. The universe deals in billions of years. The universe is approximately 13.8 billion years old. Our sun and planets formed only about 4.6 billion years ago. Many stars, and their planets, are far older than ours. Some systems could be 8, 10, even 12 billion years old. A civilization on such a world could have a head start of billions of years. Consider what we achieved in 10,000 years. Now multiply that by 100,000. Even with slow ships at a fraction of light speed, time would suffice. Expansion could sweep the galaxy in 5 to 50 million years, a blink on galactic timescales. The galaxy could have been settled long before Earth even formed. Yet the 10 billion years before us show no large-scale technological activity. Where are the elders? Where are the civilizations that should have filled the galaxy eons ago? If time and numbers favor life, something else is holding it back. The paradox deepens. Probability versus silence. Section 5, Fact 4, the logic of expansion. Life tends to expand, from microbes to humanity's spread across Earth, filling available niches. Once a species consumes much of its planet's resources, it seeks new resources, new homes, new frontiers. The stars are the ultimate frontier. Life can appear quickly. Galactic colonization math is surprisingly straightforward. As argued by thinkers like Frank Tipler and Carl Sagan, no faster-than-light travel is required. Self-replicating von Neumann probes can travel to nearby stars, use local material to build copies, and fan out exponentially. Asteroids, dust, planetary matter become raw feedstock for replication. Then the copies launch onward. An exponentially growing wave of exploration and settlement follows. At 10% light speed, the Milky Way in roughly 500,000 years. At 1%, a few million, still trivial on galactic timescales. Given our galaxy's age, there has been time for this to happen thousands of times. Yet our solar system appears untouched. No probes on the moon or in the asteroid belt, no megastructures around Jupiter. SETI hears only silence. This absence is a powerful piece of data. It tells us the logical expansion has not occurred, or not in ways we can detect. So we search for forces strong enough to halt expansion. Faced with the profound silence, thinkers proposed the Great Filter. Economist Robin Hanson suggested that along the path from chemistry to galaxy-spanning civilization lies at least one staggeringly difficult step. This step acts as a filter, stopping almost all potential life. Hence an apparently empty universe. The crucial question, where is that filter? Some step may be extremely rare. There are 3 possibilities: behind us, ahead of us, or we are in it now. If the filter is behind us, perhaps abiogenesis or the leap to eukaryotic cells, then we are among the very few to make it this far. If the filter lies ahead, perhaps nuclear arms, advanced AI, or environmental collapse doom most civilizations. The silence, then, is a cosmic graveyard. If we are in it, the hard step is becoming multi-planetary, requiring immense resources, global cooperation, and technological mastery before war or disaster strikes. Our choices in the coming centuries may decide if we pass through or vanish. The Great Filter reframes the paradox as a warning about our future. Self-destruction is possible, but there are other possibilities besides doom. What if they are hiding, hibernating, or simply unseen? Beyond the Great Filter, less apocalyptic ideas may explain the silence. Perhaps we are a protected preserve, a galactic zoo with a prime directive of non-interference. Older civilizations could be watching from afar, carefully hidden. They may communicate via technologies we barely grasp, neutrinos, gravitational waves, or physics we have yet to discover. We could be listening for radio with 19th century ears in a fiber optic cosmos. They might be shouting, "We simply lack the ears." Or their very nature is alien. Digitized minds living in vast computational substrates, inwardly focused. John Smart's transcension idea, explore inner space, space-time itself, rather than outer space. If so, no Dyson spheres, no galactic colonization. Their goals do not resemble ours, or they aestivate. In a cooling universe, computation grows cheaper. Explore, catalog, then hibernate to think vastly more later. The universe is not empty, it sleeps. Maybe the advanced simply avoid contact. There is one more possibility we must consider seriously. What if the great filter is behind us, and we are alone, or first, in the Milky Way? That possibility comes with a heavy responsibility. We must also consider the alternative, that we are alone. The rare Earth view, a long chain of improbabilities, a large moon, plate tectonics, a Jupiter-like guardian, a stable galactic neighborhood. If true, our solitude reframes the silence as an emptiness waiting to be filled. We would be custodians of consciousness for the Milky Way. That demands wisdom and foresight we have rarely shown. If we are the galaxy's only chance for self-awareness, our duty is survival. Protect our biosphere, live sustainably, endure. Ensure continuity, build, preserve knowledge, and expand carefully. Let our legacy be wisdom, exploration, and kindness, not silence. We could seed the galaxy with life and knowledge, or we could fail, and the cosmos remains mute. The paradox is a moral challenge. Act in ways that honor our potential. The empty sky may be a blank page, waiting for us to write the first word. Protect life, preserve knowledge. The Fermi paradox does not have a single, agreed-upon answer. It remains a productive puzzle, a mirror for our aspirations and anxieties, a spectrum from lonely firsts to a cosmic graveyard. But it should spark wonder, not fear, and a call to action. We now have tools to begin answering this question scientifically. The paradox asks us to learn, to keep looking and listening. Our search has only just begun. James Webb can scan exoplanet atmospheres for biosignatures. Future missions may directly image Earth-like worlds. Build better telescopes. Go farther. Whether we are alone or one of many, our future depends on choices we make now. Manage technology wisely. Protect our biosphere. Work together. If we meet others someday, let us be mature, wise, and worthy of contact. If we are alone, our responsibility to endure is even greater. Expand our view and our kindness. The universe seems ripe for life, yet appears hauntingly empty. The answer will be profound. For now, we wonder, we search, and we dream.